Hello, everyone. We are going to talk about our topic under the analyzing customer segmentation and spending patterns using machine learning techniques. And I am Malisha. Let's move into our table of content. So we are going to talk about under this work, we are going to talk about introduction, methodology, discussion, conclusion, and references. First, about the introduction. So, in this work, we aim to solve a customer spending behavior problem by predicting a customer spending score using machine learning algorithms. So, here we basically focused on understanding how customers spend by predicting their spending score using, as I mentioned earlier, using machine learning algorithms. So in order to tackle this, we use two types of machine learning approaches. One is supervised learning. So it is our goal is to make prediction based on the past data, and under the unsupervised learning, it is where we look for natural groups or patterns in our data without prior labels. So by applying these approaches, we aim to better understand customer behavior and find meaningful insights into the spending patterns. Next, about our problem statement. So, if we talk about the today's businesses, so they are eager to connect with their customers more effectively. So, but by understanding what really drives customer spending can be challenging. And they often have access to data like age, income, and the particular gender. So, but by making sense of this information to predict spending habits and group similar customer together isn't straightforward. So, with this problem, we are going to seek to bridge that gap by using the machine learning algorithm to help businesses gain valuable insight into their customers and what motivates their purchase. By predicting spending score and identify customer segments, businesses, so they can make smarter and they can make data-driven decisions to personalize marketing and to improve their outreach strategies. Next, about the objective. So the primary objective of this work is to analyze customer spending score using machine learning techniques. And the other one is categorize customers into distinct groups, allowing businesses to identify and target specific customer segments with tailored marketing strategies. Let's talk about the dataset. So this dataset contain customer information with the customer ID and age, gender, annual income, and spending score. Next, about the methodology. Under the methodology, we use as I mentioned earlier, we use two types of machine learning algorithms, supervised learning and also unsupervised learning. So under the supervised learning, we use two types of algorithm. One is linear regression, random forest, and the other one is random forest. And under the unsupervised learning, we use k-mean clustering, and the second one is hierarchical clustering. And this is the data preparation path that we use. First, we did the data exploration, and then we seeked what are the relevant columns that need to drop, and we handle the missing values, and then outlier detection and remove feature normalization and the correlation analysis, and finally split the dataset for training and testing. Here under the data exploration, so we found that within the data set, we got nearly 15 records. So this data set was taken from the website Kaggle, and age range was between 18 and 19, average of 54 years. And roughly equal distribution of gender, and also the annual income range from $20,000 to $199,000. And the spending score ranged from 1 to 100. Next, about the dropping relevant column. So here we drop the customer ID column because it likely has no predictive value for the model. So due to that reason, we drop the customer ID column. And under the missing value handling, so here we was not able to find any missing value. And next, outlier detection and the removal. Under that also, we was not able to find any outliers. And then about the feature normalization. So before the normalization in our data set, some features have very different ranges. For instance, annual income spans from 25,000 to $200,000. So, and also spending score, it goes from 0 to 100. So this difference this difference in the scale can cause issues because the model might make more attention into the annual income just because its values are very higher and not because it is more important. And after the normalization, by applying the normalization process, um, we applied min-max scaling with both annual income and spending score. We were able to get the scale from 1 to 0, and this adjustment we think it can ensure that the features has a balanced influence, allowing the model to consider annual income as well as the spending score on the even footing. So with normalized value, our model is, I think, more stable and we can have more accurate predictions. Next, about the correlation analysis. Since the values here are all near zero, it suggests that the changes in one variable don't have any clear or predictable effect on the other variables. So each variables appear to vary independently on the others. So that is what the conclusion we can give from the correlation analysis. Next, about splitting the dataset into two parts for testing and for training. So we decided around 70% was allocated for the training and 30% was allocated for the testing. Next, about the results, what we got from supervised learning. Here, so under the supervised learning, we use a linear regression as well as random forest regression. So under the linear regression, RMSE value was 28.88. So which means in under the RMSE, it measures the average difference between the predicted value and the actual values. Here on the average, predictions are about 28.88 units off from the actual values. Under the R square value, it is 0.00018. So the R square value indicate how well the model explain the variability in the data. So this value is very close to 0. So which mean the model explain almost none of the variability in the target variable. So in this case, linear regression is not performing well in explaining or predicting the target variable. And next, the result from the random variable. So there the RMSE value was 31.48. So which mean that is slightly higher than that of the linear regression. So which mean predictions are on average, so a bit less accurate. So we can conclude that part. And regarding the R squared value, it is it is minus 0.188. So which mean it is below 0. It is unusual and suggests that the model is performing worse than the simple average mean prediction. So this means random forest regression is not fitting the data well and might be overfitting or underfitting. So from these two results, the final conclusion what I can give is this neither model is performing well on this data set. So both the RMSE values and the R squared values are very close to zero or even negative. Uh, we can indicate that these models are not able to capture any meaningful pattern in the data.
Okay, now let's talk about the unsupervised learning. Here we have used two machine learning models to perform the unsupervised learning. The first one is k-means clustering, and the second one is hierarchical modeling. Hierarchical. Uh, okay, let's talk about the unsupervised learning. We have used to this analysis. We have used two unsupervised learning models. The first one is k-means clustering, and the second one is hierarchical clustering. So in the k-means clustering, we used to segment the customers into clusters using the features like age, annual income, and the spending score, and initialize with three clusters, meaning the algorithm will divide the customers into three distinct groups. Here we can see in the image, we have three distinct groups in the graph. So in the k-means clustering, the Silhouette score is measured used to evaluate the quality of clustering. So here we have the score is 0.59. The clustering result is reasonably good, but not perfect. Scores closer to 1 indicate better clustering. So when it comes to the inertia of the k-means clustering, it is it was calculated to evaluate how well the clusters were performed. So it represents the sum of squared between the data points and the centroids of their respective clusters in k-means model. So here we have the high value of the inertia suggests that data points are spread out and not tightly clustered around their centroids. And when it comes to the hierarchical clustering, to identify the natural groupings within the customer data, we have used the hierarchical clustering. The dendrogram display how the data points are merged step by step into clusters, with the vertical axis representing the distance or dissimilarity between merged clusters. So we can see in the graph, the graph as the dendrogram. And there is a major division at the top where the blue line splits, suggesting two main clusters, and three branches show hierarchical levels of merging. And at the lower levels, smaller, more homogeneous clusters merge in the orange and green colors, while at the higher levels, in blue color, larger clusters join together. The larger orange and green clusters could represent two broad customer groups with relatively significant differences between them based on the high and which the blue line connects them. And in the hierarchical clustering, here we can see the customer segmentation. In the customer segmentation for the cluster 1, it appears to contain customers with higher annual income and higher spending scores. Here we can see in rows 0, 1, and 4, we have higher spending scores, and it might represent high income and high spending customers, possibly more loyal or frequently buyers. And in the cluster 2, we can see that in these two lines contains a customer with low income and somewhat low spending scores. So it likely represent the customers with low income and lower spending habits. Then when it comes to the discussion, This study aimed to analyze customer spending behavior through both supervised and unsupervised machine learning techniques. So, in the supervised learning approach, we used linear regression and random forest regression to compare the spending scores. And despite effort to model this behavior, both algorithms showed limitations in predictive power, with linear regression performing slightly better but still exhibiting a low R squared value, indicating a lack of strong predictive relationships among the provided features. Then we'll move on to the conclusion, and the results revealed that while the linear regression model provided a better performance compared to random forest regression, and both models struggled to capture the underlying patterns in data as identified their low R squared values. And in the other hand, the K-means clustering algorithm demonstrate moderate effectiveness in segmenting customers, evident through a reasonable Silhouette score. These findings suggest that while the initial model did not yield strong predictions, they open avenues for deeper insights into customer segmentation. So, as future work, it should focus on refining these models through feature engineering, exploring more advanced algorithms, and incorporating additional customers' characteristics to enhance both prediction accuracy and the segmentation quality. And overall, this analysis highlights that while initial models offer insights, there is sus- uh, s- substantial room for improvement. So, future work should consider incorporating additional features, tuning model parameters, and exploring more complex algorithms to enhance the predictability and clustering quality. And such enhancements could significantly aid businesses in personalizing marketing strategies and better understanding customer behavior. So these are the reference. This is the reference we have used for this study, and thank you.